All right, today we're diving into something that feels, well, almost like science fiction. It's a brand new system that tackles one of the biggest and, frankly, most dangerous flaws in modern AI. We're talking about a system that can run through over 1 million steps in a row and make zero errors. Yeah, you heard that right. Perfect reliability. So let's break down how on earth they actually managed to do it. So, you know how it is. We see these big AI models, these large language models, and they just seem brilliant, right? They can whip up a poem, plan your next vacation, even spit out lines of code. It's amazing. But here's the thing. Underneath all that cleverness, they're hiding a really critical weakness, a flaw that makes them totally unreliable for the kind of complex, real-world problems where you absolutely need precision, step after step after step. And this chart right here, this visualizes the problem perfectly. There was this recent study from Apple that called it the illusion of thinking, which is such a great name for it. You see, even the most powerful models out there, we're talking top-tier stuff like Claude 3.7, they're perfect on simple tasks. But the moment the task gets long and complicated enough, they just fall off a cliff. Their accuracy plummets from 100% to 0. It's not a slow decline, it's a complete and total failure. Okay, so to really get why this happens, let's just talk numbers for a second. Imagine an AI that's 99.9% accurate on a single step. I mean, that sounds incredible, right? Almost perfect. You'd think, hey, that's more than good enough for anything. Well, it's not even close. See, in the real world, for things like manufacturing or logistics or finance, you're not talking about one step. You're talking about millions of steps all in a row. And that tiny 0.1% chance of an error, it starts to compound. Over 1 million steps, that 99.9% accuracy suddenly means you've got 1,000 errors. And worse, just one of those errors can cascade, like a domino effect, and bring the whole system crashing down. This compounding error problem is pretty much the main reason we can't trust AI for truly mission-critical jobs. So how do you fix this? Well, a team of researchers from the AI Lab and UT Austin decided to stop banging their heads against the wall trying to make the AI model itself smarter. Instead, they just took a huge step back, and they asked a completely different and way more powerful question. They asked, what if the problem isn't how these models think, but how we structure their work? And boom, that's the insight that changes absolutely everything. They figured the solution isn't to build a bigger, more powerful AI brain. The solution is to build a smarter system for organizing the work. It's a total shift in focus, from the AI itself to the architecture around it. And that thinking led to their solution, this incredibly clever system they call Maker. Now, that's an acronym for a bunch of technical stuff, but what really matters is what it does. It organizes the AI's work in a way that's, well, it's radically new and, as we'll see, unbelievably effective. Okay, so let's get into how this thing actually works. Maker is built on 3 really smart ideas that all work together. First, it takes a huge, complex problem and just smashes it into millions of tiny, little, single-decision steps. Second, it gets a bunch of different AIs to solve each of those tiny steps, and then they all vote on the best answer. And third, this is the quality control part, it has this filter that automatically spots and just throws out any confused or garbled responses from an AI before it can even influence the vote. Pretty cool, right? Now, that first step is the real secret sauce here. They call it Maximal Agentic Decomposition, or MAD for short. And the core idea is just genius. By breaking the task down into the absolute smallest possible decision and handing each one off to a little focused microagent, you completely isolate every single action. What does that do? It means that even if one agent makes a mistake, it can't cascade. It can't corrupt the whole process. It's a brilliant way to build a firewall against failure. All right, so the theory sounds amazing, right? But does it actually work in the real world? Because a great idea is one thing, but you gotta have proof. So the team set up this absolutely brutal test, a real gauntlet, to see if Maker could actually handle a truly massive long-term challenge. And for their test, they picked the Towers of Hanoi puzzle. If you're not familiar with it, it's a classic benchmark in computer science for a reason. To solve it, you have to make a huge number of perfectly ordered moves. It's basically the ultimate test of long-term planning and flawless precision. And they didn't just pick any version, they went with the 20-disk version. That specific puzzle requires exactly, get this, 1,048,575 steps. And here's the kicker. Every single one of those moves depends on the one that came right before it. If you make a single mistake at step 1 or step 500,000, the whole thing fails. game over. So, how many mistakes did Maker make across more than 1,000,000 perfect steps? The answer is 0. A perfect run. Nothing. This is, and I'm not exaggerating here, the first time any system has ever demonstrated flawless reasoning over 1,000,000 consecutive steps. It's just a monumental achievement. So, okay, this is the really crucial part. This achievement is so much more than just solving a clever puzzle. This points to a completely new future for how we think about, how we build, and how we use artificial intelligence. What it proves is that there's a whole other way to get to powerful AI. We don't have to keep playing this bigger is better game, just building more and more massive models. Instead of one giant, expensive, and frankly brittle genius model, Maker shows you can get far superior reliability using a whole system of smaller, cheaper, and more focused agents all working together. So let's bring this down to earth. What does this mean for the real world? Well, it means we can finally start building AI systems that are actually reliable enough for things like healthcare, transparent enough for finance, efficient enough for massive logistics operations. And because it uses smaller models, the system is just inherently safer. You can even run it locally without having to send your sensitive data to some giant central AI in the cloud. It is, in every sense of the word, a game changer. And all of this leaves us with a really provocative question to think about. Maybe the future of AI isn't about building bigger and bigger brains that try to mimic human thought. Maybe the real path to large-scale dependable intelligence is about designing smarter systems. Systems that, because of their very structure, are built not to fail.